Hello everyone, and welcome back to Stat385 for another video. In this video, I will be going over Lab 3. Lab 3 is going to be a little bit different than the labs that you've seen before. Normally, I go through something and there's an answer. And in this case, it's going to be a demonstration. So you will still have to follow along this video to get all the points, but it won't be inputting in something. It won't be something where you have to perform some set task. It will just be inputting in a code. Okay, so we are starting the NFL season. Football is beginning. I personally am not a fan. I know a lot of people who are watching this video are, but nonetheless, it is exciting that we are in football season. And what this lab will demonstrate is, even though we're going to be looking at the 2021 season and not the current season, what this lab will demonstrate is some more advanced, realistic subsetting things that you would see with a much more interesting data set rather than the data frame that we worked with in the lecture videos that had 5 rows and 4 columns. Okay, so let's see here. So there's 3 parts of the lab: NFL schedule. First exercise, we explore data about the 2021 NFL football schedule. To load the data into an R object named NFL schedule, use this code. However, this is before we just type this in. This code requires the NFL reader package. You can see reader. It should be like reader, but there's no E because it's the R programming language. It's this joke that never gets old. To install, we use install packages NFL reader. So I already have it. You probably don't, so you'll have to run this in an R session. So you know what? I have an R session open. I'm gonna just comment that out. You would uncomment it. Okay. And we will NFL schedule as data frame load schedules seasons equals 2021. Okay, let's load that in and see what happens here. Okay, that took it's fast, but okay, so we have some information here. 285 observations on 46 variables. Not like something that's going to tax a computer, but if I display this, it's pretty ugly, right? Like there's too many variables to display in one row. Or one viewing of this, you have to scroll up quite a bit to see all the variables. Also, not all the rows are displayed. Okay. So this is going to be one of these things where it is nice to use the viewer. Let's see what it looks like. Okay. Oh yeah, much nicer. You can see the variable names. Lots of stuff. Cool. Yeah, this is much more realistic than what we saw in class. Okay. So let's do some subsetting. Okay. Let's get call names. Let's get a much more manageable data frame. Okay. Oops. Call names. Okay. What do we have here? Game ID. Season. Okay, we're only working 2021. Game type. What was that? Oh, regular season. Okay, so we don't want the ID. I don't care about that. Game. Let's get some more interesting. Okay, regular season. Reg is regular season. You know what? I don't need to guess at this. There is a data dictionary in the lab notes. That's right, we're supposed to read the lab carefully. Okay, so first we get the schedule. To get it, you need the NFL reader package. To fully understand this data, you may need to refer to the data dictionary. You're not required to submit any code for this exercise. Watch and follow along. Then I'll give you something and then you fill that in. Okay. Schedules. Okay, cool. So it's got, whoa, this is actually pretty well formatted. Whoa, NFL reader is that part of the tidyverse? That's a tidyverse adjacent package. Anyways, we're not doing tidyverse yet. We'll do it later. But this is a general icon for what a tidyverse package looks like. Anyways, okay, so we have game type. What type of game? Is that a wild card, division, conference? Okay. I guess the descriptions aren't fully useful unless you're a football fan. I don't know much football. I do know that this is regular season, wild card, divisional series, conference, whatever. It's got some information. Regular season versus playoffs. Playoffs are a tournament. Whoever wins the tournament goes to the Super Bowl. Wins the Super Bowl is crowned a champion. Okay. Let's get... Okay, so let's do... I'm going to get some names of some, I guess, interesting variables. We'll get game type. That's kind of fun. Okay. We'll do week, game day, game time. Away team. So that's one of the teams playing. That's the team that's not playing at the home stadium. Oh, how many points they scored. Home team. That's going to be the team that plays in the stadium where the game is held. Home score. Location, result. It's total points. I don't know. And we'll get stadium, and maybe we'll do home quarterback name. This is getting unwieldy. Away quarterback name. Okay. All right, so separate these out. All right, so we're getting the names of some specific columns that I think are interesting. Location's not that interesting. You know, I'm running out of space, so I'm going to put this on a new line. Total away quarterback. Okay, cool. All right. So now I could do, and now, okay, check it out. Okay, so I'm getting a subset of the column names for things that I think are interesting. I'm combining them together, the character vectors themselves, the column names. I'm assigning them the name vars, and then I'm going to do subsetting based on the names. You know, in the notes, this was like the column names are like A, B, C, D. These are now descriptive column names for things that exist in a realistic data set. Okay, and I can view this thing much more manageable. Oh, Tom Brady, he's pretty famous. Cool. All right, still a lot of information. Let's go down to the end here. Okay, so here we have SB, Super Bowl. Away, okay, wait, this is interesting. So home team is LA, away team is LA, but they play in the same stadium. So that's weird. How does that happen? Super Bowl stadiums are probably decided at the beginning of the season, which I think that's true. And then whoever wins from whatever conference, whoever has the best record is declared the home team. So is that right? I don't know. Something like that. And LA didn't have the best record out of the two teams playing, so they're the away team, even though they're playing in their home stadium. Whatever. It's football. People who know football will know the answer, and people who don't know football won't care. Okay, that's fine. So we'll leave it there. We have a data set that we can view. Okay, well, since we said all that about the Rams, let's get a subset of this data set, isolating just the games that the Rams played. Okay, so check this out. We'll do. Okay, so it's away team and home team, right? Are those the variable names? Away team. So Rams is LA. And you can see here they're away. They played in this game. And then here they're home and they played in this game. Conference final, Super Bowl. Cool. So we'll do away team equals LA. Oh, you know what? I need to... Yeah, so this gets all the games where the away team is the Rams. And then there's going to be some stuff that you haven't seen before, but I want to get away team and home team information. Okay, and then I want either away team to be the Rams or home team to be the Rams. And so I need an or operator. And we'll call that sub. All right. How's it look? So you can see, yeah, okay, so we've got the last two values of the data set. This is where they were the away or the home team in the conference finals, and this is when they were the away team in the Super Bowl. All right, so let's do this. And now plug that in for the rows. And now we have a much more, you know what? Much more manageable, but not manageable enough. Get rid of that one. Get rid of that one. Okay, so now we have a much smaller data set where it's either away or home team is the Rams. You can see, how does this work? Oh, cool. So away score is 14, home score is 34. So its result is home score minus away score. And then total is total points. Cool. Oh, Matthew Stafford is the quarterback. I forgot he played for the Rams. I really don't know football, as you can tell. All right, so that's some subsetting. Cool stuff. To get the points, we will input in the right code. One of the creators of R, save and grade, 100%. Okay, got the points. Good. Cool. All right. Okay. So now we're going to look at roster data for the 2021 season. So we are going to, for this exercise, we will explore the data about 2021 NFL or National Football League rosters. To load the data into an R object named NFL rosters, use this command. Okay. Call this NFL rosters. Okay, cool. Right, and we have a new, we have a new data dictionary. The documentation on this is pretty good. Okay, so we have season, team. Okay, we've seen some of this stuff before. Depth chart position. Don't know what that is. Status, active, inactive. Okay. Players hurt. Full name, first name, last name, birth date. College. Oh, that's kind of cool. Official college. Usually the last one attended. Cool. Hey, we're in college, so maybe we can do something with that. Years experience, fantasy data. Oh, cool. Oh, they have all these ID variables. That's nice because, okay, I do a lot of baseball data, and there's so many different data sets, and you often need to stitch them together. And so to have a data set like this that has a whole bunch of IDs across different platforms is incredibly useful. Yeah, so that's sweet. Okay, anyways, I'm lingering on this. Okay, NFL rosters. Okay, so, oops, I ran that twice. Let's view it. Actually, let's look over here. 2,961 observations on 36 variables. That's pretty big. Okay, position. Tom Brady, he's famous. All the ID okay, so we can see. Cool. All right. Awesome. Let's do, okay, we go to a college, and college is one of these variables. So let's check that out. Cool, you can see them. So for reasons that I won't get into, and I don't know, the college will not be called University of Illinois Urbana-Champaign. In this data set, it will just be Illinois. Okay. So, okay, cool. We can see that there are some people from Illinois. Oh, I don't know, is that a lot? There's a lot of colleges. All right, so we got rows of this data set for football players who are in the NFL who went to Illinois for their college. Let's display the information. I'm going to close these out. Let's view this. Cool. Don't know what this is. NA in there? Whatever. Okay. You know, I don't like that NA. Let's call this Illini equals. Okay, so nice. In row, Illini 21. So let's call it Illini full equals Illini minus in row Illini. Okay, so the NA position, the NA value in this data set is in the last row. So I stored this data set. I got the last row, and I'm gonna say this is gonna be a character, or this is gonna be a numeric vector 21, and I'm gonna say all but 21. I call that Illini full. All right, and that shouldn't have the NA. Let's check it out. Okay, no NA. Sweet. That's actually more manageable to view in our viewer as well. I like that. That's slick. Okay, cool. Too many things going on. So too many names in this. So let's get a subset of the variables that we want to work with. Bars equals, how about team position? That's cool. Depth chart position. I don't know what that is. We'll just do position. Team and position. Status is cool. Do I want full name? Yeah, full name is cool. Oops. Okay, full name. College. And how years experience, how long they've been in the league. Okay, we'll get Illini full. Oops. Nice. Cool. All right. Whoa, some of these people have been in the league for a long time. Is this data set organized by years experience? Might be. Huh, interesting. Cool. So looks like U of I is pretty good at football. There's a lot of people who are in the NFL. Okay. How we can break this down. So this is kind of cool. So we can say position, get the positions, and then so this is a character vector, and we can say table of that character vector to count the positions that our graduates play in the NFL. Awesome. We could do the same thing for status. 13 active, 5 dev, and 2 reserve. I don't know what dev is. Okay. Cool. Okay, so there's 20 players, University of Illinois. Okay, well, there's that NA value as well. I don't know if that's a lot of players in the NFL from one college. So let's go back. Okay, let's do NFL rosters. College, right? Table. Okay, that's in alphabetical order. Sort by values. I think I can do decrease equals false, but then I have to scroll up. I think it goes in increase in order. Okay. So Alabama's got 82. Dang. Hey, here's Illinois, 20. Oh, it ignored the NA. Why was that there in the first place? That's weird. All right. Is that good? There's a lot of colleges. So for University of Illinois to have 20 players, that's decent. It's pretty good. Okay. Cool. All right. Yeah, we want to go back. We want to get the points. Robert Gent. Although this is like, I know that some of this stuff is ahead of, schedule, but this is like real. This is actually kind of realistic subsetting. I mean, I do this kind of stuff with baseball data quite a bit. Okay, Robert Gentleman, one of the co-creators of R. I got to see Robert Gentleman give a talk when I went to my thesis advisor, Charles Geyer's farewell seminar at the University of Minnesota. My advisor is an interesting character. He sat in the front row for this talk. As soon as Robert was done speaking, he stands up. No, didn't raise his hand, just stood up and just says, since Robert Gentleman's a creator of R, he just goes, I have a question for CRAN, the repository that hosts R. He's like, I have a question for R, and just starts with that. So Robert Gentleman had to now represent all of the R programming language to answer this question from my thesis advisor. He did not raise his hand to ask this question. He just stood up. I thought it was pretty funny to see it live. Okay, that's the points. Great. Okay, so we are flying through fun subsetting. All right, player statistics. Okay, again, we have a fun data dictionary. I think this, passing yards, passing touchdowns for quarterbacks. Quarterbacks of the ball, get touchdowns, score points. Cool. All right. Okay, for this exercise, we explore data about 2021 NFL player statistics. To load the data into an R object named NFL player stats, use this. Let's do it. Wrong way. I always scroll wrong. NFL player statistics. Okay, got it. We have 5,698 observations on 53 variables. Oh, these data sets keep getting bigger. It's fun. All right, how does it look? Let's see here. We have numbers. That makes sense. Okay, too big. I'm not going to put it in the viewer because we already know it's too big. All right, call names. Okay, so again, I don't know too much football. I do know that quarterbacks are the most valuable position. We'll look at quarterbacks. All right, so we're do vars. Okay, I don't want player ID. Player name, it's a good one. We'll do position because we'll need it to find the quarterbacks. Okay. Completions, how many passes they threw that were successful. Attempts, how many they threw in total. How many yards, the distance of the passes that they were completed in throws. How many times they scored. Interceptions, how many times they made a mistake and threw the ball to the other team. Okay. Okay, and then let's get, these are fun, but let's get, is there like an aggregate measure that like tries to do like a value, like an overall value? This looks like something. Adjusted EPA composite based on coefficients would best predict. I have no idea. Don't know what that is, but that sounds cool. Okay. Okay. And then I think I saw weighted opportunity rating. Okay, that's a formula. Looks fun. I don't know what it is, but it's going to be something different than just a simple counting statistic. So get those. We will do, okay. Okay, I said I wanted to focus on quarterbacks. So that's, so here's the data frame. I guess I will do this. Position equals, I believe it's QB. Yep, okay. Now I will highlight the row, or subset the rows of the people who play quarterback, and we'll get our bar columns. Make sure we run this. Okay, cool. And let's view that. All right. Oh, this is broken up by all the games. Cool. Oh, what? Oh, that stinks. That's no fun. Okay, I can't tell how is this thing computed? Okay. This person went 10 for 11, which is a really high percent, although it's limited opportunities. Passing yards, 125. I think that's good. And 10 completions, maybe not. 1 TD, 0 interceptions. This one, okay, 21 for 25 with 308 yards. That's a good game. Oh, 5 touchdowns. That's a good game. Okay, so a high value of Dakota indicates a better game. Ooh, yikes. What did this person do? 5 for 21 with 2 interceptions. Yikes, that's awful. All right, anyways, there we go. Cool. All right, so let's get, okay, that Dakota thing was kind of fun. I like that. Let's do, Dakota. Oh, cool, that's right. I don't have to specify the full name when I do this type of subsetting. As long as I specify the name up to the unique characters that identify that variable, I'm good to go. See, it just pulled Dakota. I didn't even specify it all the way. Does it do it with DA? Yep. Do it with D? Yep, because it's the only variable that starts with D out of all the ones that exist. But just to be careful, I'm going to do Dakota. Okay, so let's do something like this. Summary table. Okay, so third quartile is a Dakota value of 0.182. Max is 0.43. Let's do... Dakota greater than 0.25. Actually, let's just do third quartile. Just copy that directly. Okay. This is ugly, but it's going to be fun when we're done. You know what? No, this is getting unwieldy. Okay, I'm going to call this data frame QBs. Okay, let's look at QBs. Okay, it's the same. Okay, so it's that subset of data. I'm going to do QB's $ Dakota greater than that. Okay. And we're going to do this. Oh, what did I do wrong? Yep. Okay, there we go. So this is, let's view it. Okay, so this is all, oh, there's NAs in here. Weird. I don't like that. That's no fun. Okay, anyways, we can see with a mixture of NAs, all the essentially the top 25 percent of highest quality games according to this Dakota metric. Okay, cool. That's fun. So let's do this and get the player name, and let's do that thing that we did earlier, table sort. And this will be, so Matt Stafford had a really good season. He had 11 games with a Dakota score in the third quartile or better. Granted, he was in the playoffs and got more games, but 11, that seems like a lot. Pat Mahomes had 9. That's good. Cool. All right. Nice. All right, that's probably good for this. So that's advanced subsetting, or realistic subsetting on a realistic data set. All right, so you want to get the points. So in honor of that hilarious story that I told earlier about my thesis advisor talking to Robert Gentleman, he will be the code. What happens? Okay, just 1 second. I'm gonna have to pause the video and figure that out because I just changed this. Give me 1 second. All right, sorry about that. Charles Geyer, saving grade. Good. All right. Yeah, something happened with Prairie Learn. Don't know what. I changed it so that it would do that. Anyways, okay. So I have all the points for Lab 3. If you followed along, you should have all the points for Lab 3 too. If for whatever reason this glitches again, please let me know. I'm sure you will. All right. Well, thank you for watching this. And I'm glad that even though, I like to have the lab assignments be something where you're doing work and submitting things, I think it's nonetheless very useful to see like how subsetting works in realistic, much more realistic settings with a realistic data set. All right. Thank you for your attention. I will see you next week. All right. Bye.